Hey guys, Mr. Beckwith back again. So this is kind of a squeaky loud. So this is kind of a refresher on mixtures, and we're going to look specifically at some of the physical properties of mixtures, and hopefully that will show us the best way to separate those mixtures. And then we've got some tools here that we're going to use to actually separate them. Alright, so the first thing I'm going to do is I need to create a few mixtures. Alright, so I've already got a few. I've got wood marbles and glass marbles. I have got copper pennies and iron paper clips. I've got iron nails and wood toothpicks. I've got seashells and sand. And then I've got some ingredients for a few more. I also have this giant thing of beads, of colored beads, that we're going to talk about how to separate. I'm not actually going to separate 1,500 different colored beads, but we'll talk about it a little bit. We've got sand and iron filings here, and I'm going to create a couple of mixtures just really, really quickly. So while we're doing that, I want us to just think about some of the different physical properties that we could potentially use. And I'm going to do 5 milliliters of each on these. Some potential physical properties that we could use to separate some of these mixtures. So some of the properties I want us to think about are density, because some of these items are more dense than water and some are less dense than water. I want us to think about magnetism, because some of these items are magnetic and some are not. I want us to think about solubility, because some of these items are soluble in water and some are not. And then some more basic things to think about is just, are the items a solid or a liquid? We're not dealing with any gases today, but physical state is definitely something we could also consider. Alright, so we are going to start with our salt and pepper. Now, for salt and pepper, what do we know about salt and pepper? Well, we know that salt dissolves in water and pepper doesn't. They're both solids. They're both, well, I take it back, not both. Salt is actually more dense than water, because if you put too much salt in it, what doesn't dissolve will sink to the bottom. Pepper, because it's kind of a blend of some different things, some of the pepper will float on the top and some of it will sink to the bottom. So, which of those properties could we potentially use? And if you said solubility, you were right. And it was also the first thing I said too. That was also a massive hint. So, we need some water. I just happen to have a pretty large container of water here. So, what I'm going to do is I'm just going to use this cup. Now, I put 5 milliliters of salt and 5 milliliters of pepper in here. So, it's a pretty good little mixture. And I'm just going to fill this cup up, not completely full, because I don't want it to spill and make a mess. But I'm gonna fill it up pretty close to the top. Now, I need to stir it up so that I can make sure that the salt is dissolving inside. Now, for those of you that did our solubility lab, you know that some of the ingredients in pepper will actually dissolve. Most don't, but some of the coloring that's in it will dissolve, and so we'll end up with kind of this weird coloring. So we're going to have a little bit of other stuff in our salt water. So, now that I've got this, I need to filter out the pepper. So, coffee filter. Basic function of a coffee filter is it separates liquids from very small, tiny particles that are solid. So it separates small solids from liquids. So I'm going to put my coffee filter in, very carefully so I don't make a mess. Pour in my salt water and my pepper mixture. That's going to be a little bit of gross residue at the bottom there, but I know it's all pepper, so that's all good. And then I'm going to pull this up to strain out. Now, as you can see, this salt water has got some coloring in it because some of what was in the pepper did dissolve in the water. So pepper, for the most part, is not soluble in water, but a little bit of it is. But for our purposes today, this is just fine. Now I'm going to try to squeeze this out, this remaining water, without making too much of a mess. Just put a little pressure on it to squeeze out the last little bit of water. So hopefully you can see that even though it's this darker color, it's very clear. There's no large solid particles in there. So those large solid particles, they're either in this cup or, oh yeah. And I'm going to peel this filter out so you can kind of see. So there's my pepper. So I have successfully separated my pepper from my salt water. Now, if you watched the solutions lab, you already know the answer to this question. But how would I separate out the salt water, the salt in the water, and this pepper coloring that's also in there? How would I separate that out? I would evaporate it. I would boil it out. Now, if I boil it out, the water's going to evaporate up. It's going to turn into a gas, into water vapor, and then whatever's left over in here, the salt and whatever that coloring is, it'll be left in the bottom. And then there should be 5 milliliters of salt in the bottom of this. There should be about 5 milliliters of pepper in this, except for the little bit that maybe is in here. Because whatever we put into a solution, when we separate the mixture of the solution, that's what we should get back out. That pepper and that salt are not evaporating up into the air with the rest of the water. All right? So, there's one down. Set those off to the side. Let's talk about the colored beads. We're not actually going to do the colored beads because there's 1,500 of them and I'm not separating out 1,500 beads. But I've got some tools over here. If I can get my bead to stand there. I've got some tools over here. I've got this this strainer filter. But that doesn't really help me. That doesn't really do anything. That just, that doesn't really help me. I've got a magnet, but these beads are all plastic. So I've got some ceramic magnets. I'll explain why I've got them in a bag in a minute. But that's not really helping because they're not magnetic. The funnel doesn't really help me because the beads are all the same size. I mean, I could put a few of them in there, but they're just going to fall right through the bottom. But I also have these forceps here. I have these tweezers. Now, this would be very tedious, but if I was just going to start separating, let's say I wanted to separate all the green out, what physical property of these beads allow me to use these forceps? Not sure? I'll give you a hint. Got it yet? It's that they're a solid. I can only grab these with the forceps because the beads are a solid. Now this may seem like a simple thing, but it is because of the physical property of the physical state. Because it's a solid that I can use the forceps to sort out the beads. Now, like I said before, there's 1,500 of these, and I'm limited to 15 minutes on the length of these videos. So, you get the idea. If I really wanted to, and if I was really bored, maybe I would sit here for a few days with my forceps and separate. But I'm not going to. You get the idea. So, there's my plastic beads. Now, what else have we got over here? I guess we could talk about, since it's nice and close, we could talk about my glass marbles and my wood marbles. So I've got several different sizes on my wood marbles. Now I could use the forceps. I absolutely could use the forceps to just kind of pick them apart. I mean, I could use my hands if I really wanted to. So you could make an argument that it's the physical state, the fact that they're a solid, that you could separate them. But there's another option. And I think a much faster option. Because the marbles are made of glass. And the beads are made of wood. Now they're both solid. Neither one of them dissolves in water, so why do you think I pulled the water over? Because the wood's less dense than water and the marbles are more dense? Oh, you're so smart. That's exactly right. So if I took my mixture and poured it in, what's going to happen? Well, I've got my wood beads floating up here on the top, and I've got my glass marbles down here on the bottom. Now, some of my wood beads are kind of hanging out in the middle, which means they probably just were soaked with too much water. But here's my wood beads now. all separated. And there's my glass marbles on the bottom. So because the wood is more dense than the water, I'm sorry, because the wood is less dense than the water, and because the marbles are more dense, I can use density to separate this particular mixture. Alright, now, while I'm making a mess over here and trying to clean it up, with as little noise as possible, I have another one for you to think about. I've got in this cup copper pennies and iron paper clips. Now, very similar to the beads and the marbles, I could use the forceps, right? I could pick these out one at a time. I could pick out the pennies one at a time. They're both solid, so I could. But is there a better way? Is there an easier way, a faster way? Is there a different property that I could use? Well, what property is it? How about magnetism? But Mr. Beckwith, they're both made out of metal. Aren't all metals magnetic? No, not all metals are magnetic. There's actually only 3. And if you've been in my class this 6 weeks, you should know what the 3 magnetic metals are. The first one is iron. The second one is nickel. And the third one is cobalt. Which means copper is not one of those 3. So you're telling me that copper is not magnetic? Well, let's see. Copper penny. Here's my ceramic magnets. Huh. Well, maybe these magnets are defective. Nope, that's not it. So let's give it a whirl. If the paper clips are made of iron...
DMAC training will be held in Computer Lab 1. Thank you.
Huh. That was Ms. Middleton, by the way. She's freaking awesome. Just saying. So I could, in the matter of about 5 to 10 seconds, I have just removed every paper clip from this mixture. And now on left are my pennies. Iron, magnetic. Copper, not so much. Remember, our only 3 magnetic metals are iron, nickel, and cobalt. Okay? Now, we've got some more mixtures here. But a lot of it's just repeating what we've already talked about. Alright? Sand and iron filings. Iron filings. What kind of filings? Iron. Iron is what? One of the 3 magnetic metals. So I can very easily pull these iron filings out. Now, I told you I would tell you why I had the baggie. I'm fixing to show you. Here's a tip. If you're ever going to use a magnet with iron filings, don't ever put the magnet directly on the iron filings. The iron filings are teeny tiny. They're like teeny itty bitty pieces of dust made of iron. Once they stick to the magnet, it's incredibly hard to get them off. You end up having to like peel them off with your fingers. They get all on your fingers. It's disgusting. However, and thank you, Miss Shelby Thayer, for teaching me this trick. If you put the magnet, and I'm actually going to trim my magnet down so it's not so bulky. I'm just going to use 3 of them. If you put the magnet inside a baggie, see all that? Now I've got my iron filings. Now if I want to take them off, it's just a matter of holding the baggie and pulling your magnets away. And now your magnets completely clean, all your iron filings back in the bag, not scattered all over your table, which is very nice because the iron filings are tiny and very challenging to pick up. So, whenever you're using iron filings, magnets inside a baggie, always a good decision. Alright, so we've used magnetism. Now, I've got iron nails and toothpicks. So I can use magnetism here, but what else could I use? I could also use density, right? Wood's less dense, iron's more dense. Toothpicks float to the top, iron nails sink to the bottom. A few of my toothpicks got stuck on my nails, but all I need to do is just kind of move them around a little bit, let them float up to the top. And my mixture separated. All right. And then we've got one more. Sand and sugar. Now, sand and sugar are both very small, solid particles. But sugar does something that sand doesn't. What's it do? It dissolves in water. I'm sorry, did you hear that? I said it dissolves in water. So, I've got my sand and my sugar. I want to dissolve it in some water. So, a little water. A little mud here. Stir it up. My sugar is going to dissolve in the water. The sand is not, because the sand is not soluble in water, but the sugar is. So I'm going to end up with this sandy sugar water. Once again, coffee filter does what? Separates a liquid from a very small particle size solid. Put my coffee filter in. Pour my sugar water and my sand into it. The sugar water is going to drain through. And most of the sand is already sinking to the bottom. So I could just leave it there. But I want the effect of seeing it in the filter. So I'm going to get as much of that sand in here as we can. Come on. Very cool. Alright, strain out our last little bit of water. And once again, you see the water. Pretty clean, not completely clear. Probably a few things in that sand that maybe dissolved as well, but for the most part, just sugar water. And there's all of our sand. So, properties of mixtures. The physical properties of mixtures don't change when you mix them together. Now, when you're dissolving something, you create a special mixture called a solution, and the physical properties will change. Feel free to check out that video also. So, physical properties don't change in a mixture. Now, when you're separating those mixtures, the trick is, think about the things that are different. Think about the properties that are different. Is one material more dense and the other less dense? Is one material magnetic and the other material not? Does one material dissolve in water and the other does not? Is one a solid and one a liquid? There are all kinds of different ways that you can separate these mixtures if you understand how their physical properties work and where their physical properties are different. Alright, guys, hopefully this video was helpful. If you liked it, please click like, and if you are one of my students and you have not already, please subscribe to this channel. Thanks, have a great day.